Hello and welcome to the practice test answers. Your assignment is to grade somebody else's paper, so I want you to pay attention to the details and to the points so that we can give good feedback to somebody and have them give them a chance to be able to work through things and be able to prepare for the test well. So, the first question, you are being asked to make a table. Here's the table of points, and then we should plot at least 3 of these points, preferably 4. I'll be looking for 4 points on the test. So -2.8, -1.4, 0.2, 1.1 are for sure, and then you could get 2 like 0.5, something like this. 2 points for a table shown and a graph correctly graphed. Then each of these are going to be worth half of a point each for a total of 4. The domain is -infinity to positive infinity. The range is 0 and above, so 0 to infinity. It's never increasing because the whole time it's decreasing from -infinity to positive infinity. Whoop. There's no x-intercept. The y-intercept, they should say a point. Don't just say 2. It's a coordinate 0, 2. Take off a half if they don't say that. As x approaches infinity, our graph approaches 0. Because as this is going farther and farther right, the graph is going closer and closer to 0. As the x approaches -infinity, as it goes left, it shoots up and it goes towards positive infinity. So here together, half a point each, a total of 4. The graph and table together make 2. So 6 points for the first problem. Second one, same thing. Here's our table. We have a number of points here. We've got our graph connecting them and going up. The domain, again, -infinity to positive infinity. It goes all the way left and all the way right. The range, though, only goes from 0 to positive infinity. It's increasing the whole time. It's always getting bigger and bigger and bigger and bigger and bigger. It's never decreasing. There's no x-intercept. The y-intercept is the coordinate right here, 0, 1. Again, that needs to be a coordinate. And as x approaches infinity, the function approaches infinity. As we go right, it goes up. As we go left, it gets close to 0. So we should have a score of 12 points on this first page. At the bottom of the first page, give how many points they got right out of 12. Page 2. Each of these are worth 1. It's a 4-point problem. This is growth. Anything bigger than 1 in here is growth. If it's less than 1, it's decay. The growth factor is the number 1.03. How much is that above 1? 0.03 above 1, so that is the rate. What's the initial value? 2.4. 1 point each. This one, it's less than 1 in here, so it is decay. The factor is 0.57. We subtract it from 1. It is 43 less than 1, 0.43 less than 1, so this is the rate. The initial value is 35. You can pause this at any time if you need to be able to score it. The next one, we've got this investment, $3,000 at 4% interest. Remember, this makes a decimal of 0.04, which is why this is 1.04 to the x. To find the average rate of change between 2 and 5, we find what's the value of the function when x is 5, 3649.9, or they could have 3650, that's okay. What's the value of the function when x is 2? I got this. Then we subtract those numbers to find a change of 405. I had 405.1 divided by, there are only 3 x values, so we subtract the x values underneath. So when we have this total increase divided by 3, I got 135. 2-point problem here. I'm looking for 1 point for the setup and 1 point for the correct answer. Okay, we've got an equation here for a car. It's purchased for $24,000, so that's our initial price right here. It's depreciating at a rate of 8%. So remember, 8%, we change to a decimal of 0.08. Subtract it from 1. It gives us a factor of 0.92. This is 3 points for having the correct equation. Now, if they have the wrong equation, then we got to play with those numbers a little bit. Because the value of the car after 3 years, we're going to plug 3 in here for x in the calculator. If you do it correctly, you should get 18,688. But if this formula was wrong, you could still give them the right point. If you plug it in and it works to get this number, and they did that part right, they can still get the 1 point here. How many years later before it's worth less than 15,000? Again, you'll have to use their formula to see if they did it right. But if they did the correct formula, you should find 5 years at 15.8 and 6 years at 14.5. So it's going to take that 6th year before it drops below $15,000. 3 points for the equation, 1 point for each of these. We should have a total of 15 on this page. Score it up and give them a value out of 15. Okay, again, we've got 1.3%, so we need to change that to a decimal. This decimal is going 2 places back. It's 0.013. We add that to 1 to go into the equation. This is 1.2 billion. And here's the rate to the x. So this is 3 points for having that equation correct. When you plug in 1 up here, okay, it'll give you a big number and 1,200,000,000 plus some extras. So I put in 1 here, I found that number, I subtracted it from the original amount of 1.2 billion, and I found it was an extra 156 million. So the total population after 20 years, we're just putting 20 in there and figuring out the whole thing. And after 20 years, it looks like it'll be 1.5 billion. 1,555,710,688. 3 points for the equation, 1 point for each of these. We've got this thing that decreases 10% each time. So that is less than 1. It's decay. So we put 0.9 in here. Our initial value was 130,000. 3 points for the equation. 2 points for filling in the correct points here. If they have a different equation, check it in their calculator, see what they're, and then go to the table and see what it is. They can still get credit for this, even if their equation was wrong. Then for 12, I put 12 in as x and figured it out, and that it should be 36,712 lux if there are 12 sheets. And then looking through the table, you can find how many is needed to reduce it in half. Well, half of 130,000 is 65,000. So you can look in the table and see where is it that it hits below that. At 7 years, it drops to 62,000, so that's how long it takes to cut in half. Another way to ask this question, you might see it asked as saying, what is the half-life? Calculate the half-life. We would say it's 7 years before it's cut in half. Every 7 years, it's going to be cut in half again. A house costs $200,000. It will appreciate. Appreciate means go up. Depreciate means go down. We change this to a decimal. We put that in, add it to 1. So here's our equation. That's worth 3 points. We plug in the 10 in for x, and we find our equation. We get 282,119. 3 points, 1 point. Total on the page is 16 points. Give them a score. Here you can find any method you like. So if I'm looking at these numbers, I take 144 divided by 24, and I see, oh, that's 6. So we had to have multiplied this one by 6. Multiplied this one by 6, multiplied this one by 6. So the growth factor is 6. I can find B is 6. Then to find, well, I want 0, that would give me my initial amount. So I could divide this one by 6 and say, when it's 0, it'll be 4. So A is 4. So here's my equation. 4 times 6 to the x. That's a 2-point problem. 1 for A, 1 for B. This thing, the same thing. We're multiplying by 0.5 every time. So if I divide by 0.5 to get me back to the initial value, I get B is 0.5, A is 4. Here's my equation. That's also worth 2 points. So we've got 2 points and 2 points. Here's where you have to use your brain a little bit as you're grading. It's a 4-point problem here. Okay, I'm looking for 1 point for the initial setup. Did they put up those equations correctly? 1 point, did they get A by itself correctly? Okay, so that's the second point is, did they do this right? We know that B to the negative 1 means it's really in the denominator. So then we got to multiply by B to get it out of the denominator to get A by itself. If they did that right, they get a point. They plug it in. Then the next to this part is, did they wiggle this around correctly? We know this is a fraction. We can multiply and add the exponents. So then to get B to the 4th by itself, multiply by 2 on both sides. That's 256 is B to the 4th. So take the 4th root of both sides, which gives me B equals 4. The last point then is plugging it back in and getting A is 2. Here's our final answer. Y equals 2. times 4 to the x. The next one, 1 point for setting up our equations correctly. We know b to the negative 2 is really the same thing as being in the denominator. So if I want a by itself, I have to multiply by b squared on both sides to get it out of there. So we have a by itself. They get a point for having this right. We substitute over here. We multiply, gives me b to the 4th. Then to get rid of the dividing by 4, we multiply by 4, which gives 48. And then divide by 3 to give 16. And then take the 4th root. The 4th root of 16 is 2. They get a point there. Plug it back in for a. And when you solve for a, you should get 3. So our equation y equals 3 times 2 to the x. This page has 12 points on it. Give them a score out of 12. Last page. These are 5 points each. 3 for the equation, 2 for answering the question. Now this says use x to represent years since 2005. So in 2005, my x value is just going to be 0, because it's 0 years since 2005. In 2010, my x value is just going to be 5. Here's 2 points. It says that it's happening linearly, so I need to find the slope. y2 minus y1 over x2 minus x1. I get my numbers, I divide by 5. This is my slope. So I have my y-intercept was already here. Here's my m, here's my b. I can put them right into the equation. Y equals 2160x plus 36,000. That's 3 points. Then for the extra 2 points, it says predict 2015. So when that happens, x will be 10. So I can plug in 10 in for x, and I get an answer of 57,600. So 3 points here, 2 points there. For the exponential one, I've got 2 points again. I use my process to figure out I can set this up. A times b to the 0. Anything to the 0 is 1. So this is a is equal to this. We can set this one up from those points. Plug this in. We get this. Divide. We get 1.216. Take the 5th root of both sides to get b by itself. I got b is 1.04. So here's my equation. My a and my b. 3 points if they had this equation correct. Then we can plug it in. If x equals 10, we'll put 10 in for x, and I got 53,290. So in this case, the linear growth is actually a little bit faster than the exponential because it's too short of a time period. Eventually, the exponential is going to take off, but in the short term, for 5 years right now, in this problem, the linear is a little bit higher. This is 10 points, 5 and 5, give them a score. Now you should go back and you should have scores for the whole thing. The total should be 65 points. Add them all up, give them however many out of 65, and then divide that to get a percentage. We will use that percentage tomorrow. Have a great day.